Main focus of the task in this training is as follows. First, to reduce errors in data, examine the problem with several trials instead of finishing it with a single trial. Second, testing instruments such as digital thermometer must measure the same points during both normal operation and fault finding. Third, when measuring wind speed, it is necessary to measure the wind volume at several places as much as possible, rather than only one place, and to make an average value. Fourth, when installing a manifold gauge, install it where the refrigerant in the hose can be reclaimed. Fifth, after the repair is completed, competitors should always check if the machine operates properly. Sixth, to figure out the reason for the fault, it is necessary to train workers by comparing the normal refrigeration cycle and the refrigeration cycle which has a mechanical fault. Please check the preparations and tools for this training. These are precautions. First, before repairing the fault, competitors should attach a danger sign at the end of the power cord. Second, since this work deals with the refrigerant, make sure to wear a safety gear to prevent low temperature burns. Third, the sensor for temperature measurement should be attached to the exact position. Fourth, before using measuring equipment such as a thermometer and a manifold gauge, make sure to adjust it to 0. Fifth, when supplying power, make sure to wear insulated gloves. Sixth, before and after supplying power, make sure to conduct the electrical short test and insulation test. Seventh, the likely cause of failure is high pressure, so be careful of changes in high pressure. Eighth, operating faulty equipment for a long time to find the fault can lead to the additional damage to the machine. Ninth, care must be taken in insulating the sensor parts so that the temperature measurement data values are not affected by external factors. Please check what you are going to perform on this task. Connecting gauges used for identifying the fault. In order to identify the mechanical fault in the machine, disassemble the cover and install the required equipment. Install a thermometer. In order to reduce errors in measurement, use a digital thermometer which has a contact-type temperature sensor. The disassembled cover should be temporarily assembled again for accurate measurement and safety of the competitor. The thermometer should be installed on the same place in both normal and damaged machine. It should be insulated around sensors so that the temperature does not change by external factors. The thermometer should be installed at each outlet of evaporator and condenser. Connect the sensor to the thermometer to check if it shows the current temperature accurately. To check the operational current of the machine, install a clamp meter. Connect the manifold gauge. Connect the blue low-pressure hose to the service valve. Attach the valve core removal to the high-pressure side, then connect the red high-pressure hose. Inspect gauges and connecting parts thoroughly with a gas detector to check if there is any gas leakage in the connections of the manifold gauge. Examining the normal operating condition. Write data of the equipment in normal condition. Measure and write down the compressor operating current, the air velocity of indoor and outdoor unit, the high and low operating pressure, the superheat, and the subcooling. When measuring the air velocity of indoor or outdoor unit, divide the inlet or outlet of indoor or outdoor unit into 4 to 6 sections, and measure the air velocity in each divided sections to get an averaged value. If you multiply the average value with the area of indoor unit, you can get the average air velocity of the machine. The situation of the fault regarding to the decreased air volume in condenser. Put a paper over the outdoor unit to intentionally decrease the air volume of condenser. Check how the data gets changed compared to the data from the normal machine. There can be several reasons for the decreased air volume of the outdoor unit, but it commonly experiences an abnormal increase in the discharge pressure, which is a high-pressure part. Reasons for the decreased air volume of the outdoor unit. When the motor does not rotate properly because of the functional problem in motor. When the wing of the fan is damaged. When the pins on the suction side of the outdoor unit are clogged with foreign substances. When the outdoor unit is placed in a problematic location. Measure the compressor operating current. High pressure rises due to a lack of heat exchange, causing the compressor operating current to rise as well. If the place where the condenser is installed is not ventilated and has a lot of dust, the contaminants will stick to the refrigerant pipe and cooling fin. In this case, the heat does not exchange, rising the high pressure. If a leaf or a paper is stuck to the condenser, the heat does not exchange as well. As a result, condensation will not take place well, but the pressure at the high pressure part will increase. Let's compare the data of when the air volume of condenser is decreased with when the condenser is operating normally. Check for any noticeable changes. Increase in discharge pressure. Increase in compressor operating current. Decrease in air volume of condenser. No change in the degree of supercooling of the condenser. No change in the degree of superheat of the evaporator. The reason for the data change is because the heat exchange is not taking place properly at the condenser. The condensing medium of an air-cooled condenser is the air that exchanges heat. If the air volume is not adequate, the condensing efficiency decreases and the discharge pressure increases. If the condenser is placed close to a wall or any other obstacle, the hot air discharged after the heat exchange gets sucked in again, making the heat exchange ineffective. When there occurs symptoms such as the increase in discharge pressure, the increase in operating current, and the decrease in the air volume of condenser, the contamination in the condenser or the faulty condensation are assumed as the reason for the fault. In this case, there is no change in the degree of supercooling of the condenser and the degree of superheat of the evaporator. The situation of the fault regarding to the refrigerant overcharging. Overcharging the refrigeration system with refrigerant intentionally makes the machine in a dysfunctional state. The overcharged amount of refrigerant is 600 grams. Check how the data gets changed compared to the data from the normal machine. Measure the discharge pressure and the suction pressure during operation. If the refrigerant is overcharged in a refrigeration cycle, the discharge pressure gets abnormally high. Measure the temperature of the condenser outlet. Although the temperature dropped only a little bit, the degree of supercooling changes considerably due to the change in discharge pressure. Measure the compressor operating current. the operating current is higher than normal. Let's compare the data of when refrigerant is overcharged with when the machine operates normally. Check for any noticeable changes. Refrigerant is overcharged 600 grams more than the normal amount. Increase in discharge pressure. Increase in the degree of supercooling of condenser. Decrease in superheat of evaporator. Increase in compressor operating current. Normal air volume of the condenser. It is because of the excessive amount of liquid refrigerant that had accumulated on the condenser, decreasing the capacity of the condenser. It is because the part of the condenser where the liquid refrigerant is filled cannot work properly as a condenser. Therefore, when the subcooling increases excessively, the liquid refrigerant which was unable to be evaporated keeps flowing into the compressor. When there occurs symptoms such as the increase in discharge pressure, the increase in subcooling of condenser, the decrease in superheat of evaporator, and the increase in compressor operating current, the refrigerant overcharging is assumed as the cause of the fault. In this case, there is no change in the air volume of the condenser. The situation of the fault regarding to the mixed-in non-condensable gas. Inject some nitrogen gas into the refrigeration system intentionally to make it in a dysfunctional state. When non-condensable gases such as air are collected in the condenser during piping, the condensation volume of the condenser is reduced due to the non-condensable gases, which results in higher discharge pressure than the pressure corresponding to the condensation temperature of the refrigerant vapor. Check how the data gets changed compared to the data from the normal machine. While the machine is operating, measure the discharge pressure, the temperature of condenser outlet, the suction pressure, the temperature of evaporator outlet, the compressor operating current, and the air volume of both compressor and evaporator using a manifold gauge. Why non-condensable gas can cause some problem? It is because non-condensable gas gathers at the upper part of condenser and interferes with the condensation of the refrigerant. If the amount of non-condensable gas increases, the heat exchanging area decreases, hindering the heat exchange efficiency and the condenser's performance. Therefore, it can be the cause of decreasing the refrigerating ability since it increases the condensing pressure, increasing the shaft power of compressor as well. However, there is no obstruction at the part where the wind goes out, so there is no change in air volume at the compressor or evaporator. Let's compare the data of when some non-condensable gas is mixed in with when the machine is operating normally. Check for any noticeable changes. Increase in discharge pressure actually. Increase in subcooling of condenser. Suction pressure hunting phenomenon. Increase in superheat of evaporator. Increase in compressor operating current. No change in the air volume of the condenser. To prevent some non-condensable gases from being mixed in, seal the refrigerant piping system properly and make sure there is no remaining air or non-condensable gases by sufficiently conducting the evacuation procedure. When the refrigerant being charged, be careful so that no air or moisture is mixed in. When there occurs the symptoms such as the increase in discharge pressure, the increasing in subcooling of condenser, the suction pressure hunting phenomenon, the increase in superheat of evaporator, and the increase in compressor operating current, the mixed-in non-condensable gas is assumed as a result for the fault. In this case, there is no change in the air volume of the condenser. After completing the task, the tools and measuring gauges used for examining and repairing the fault should be removed. All sorts of covers or caps that were disassembled, such as a pressure controller and joint box, should be reassembled to the original state. We have reviewed 3 reasons the cycle of the refrigeration unit is operated with high discharge pressure. There are three main reasons why the cycle of the refrigeration unit is operated with high discharge pressure. Decreased air volume of condenser, refrigerant overcharging, mixed-in non-condensable gas. These read differences in the measured data depending on three reasons above. If the condenser air volume decrease is the cause, it shows the problem such as increase in discharge pressure, increase in compressor operating current, and decrease in air volume of condenser. No change in the degree of supercooling of the condenser. No change in the degree of superheat of the evaporator. When the refrigerant is overcharged, increase in discharge pressure, increase in subcooling of condenser, decrease in superheat of evaporator, increase in compressor operating current. But the air volume of condenser is normal. When some non-condensable gas is mixed in, increase in discharge pressure, increase in subcooling of condenser, suction pressure hunting phenomenon, increase in superheat of evaporator, increase in compressor operating current, no change in the air volume of the condenser. Even if the discharge pressure is high, there can be a difference in the specific data depending on the situation. In order to quickly find the fault and its reason, it is necessary to understand the problems that occur according to situations and to be trained repeatedly by comparing the difference in the measured data. Check again the key points of the task we've worked on in this training. In this training, we have learned the high pressure, which is how to diagnose the failure of air conditioning unit. Everybody, thank you for your hard work.